So today's presentation is by Sibonelo Dlamini, The Promise of Transfer Learning for Improving NLP for Low Resource Languages. Sibonelo is a lecturer in the Department of Computer Science at the University of KwaZulu-Natal, Westville campus. He's currently a PhD candidate working in the field of natural language processing, and his research is focused on exploring the use of cross-lingual transfer learning to improve the performance of natural language processing solutions for low-resource languages. And he uses isiZulu as a case study. So I think he's going to talk about that now. Let me stop my share so that he can actually take over.
Hi, Mino, can you hear me?
Yes, I can hear you. Can you hear me?
Yes, absolutely.
Yeah. Okay, no, that's all fine.
Okay.
Please share your screen.
I am sharing, and
yes,
yeah,
I can
see
something.
Yep. Yeah, you can see it.
Yep, I can see it. Wonderful. Thank you.
Thank you very much. So good morning, everybody. As Mino has said, I'm Sibonelo Dlamini from UKSDN, the Department of Computer Science. And this morning, I want to share with you the promise of transfer learning for improving the performance of NLP for low resource languages, which is, I think, very important because all of our languages, all of our official languages, excepting English, are low resource or can be classified as low resource languages in South Africa. So what is the context of this talk? Well, we know that a lot of great human language technologies have been developed recently. If we can just think about Google Translate, there's also speech to text, which is something that we use not only on like our Apple Siri, but any smartphone pretty much has speech to text now. We also have some what we can call low-level technologies like auto-completion, but that are actually very useful, especially for our smartphones that have a touch screen and are difficult to type on. If we have auto-completion, these words being suggested to us, that really does help us to type out messages quickly. But the problem with these technologies is that they are mostly available for English and other very, very highly resourced languages, which means that if you don't know how to speak English, you're not proficient at English, then you're not going to be able to take advantage of these technologies. Now, why is it that these languages are so great for English? Well, that's basically due to the fact that a lot of them, actually all of them, are built on top of machine learning models or machine learning algorithms, and machine learning algorithms need a lot of data in order to be trained to perform well. Now, we also need natural language technologies in our indigenous languages. For example, we know that interface between, or humans are increasingly interfacing with computers through speech. So instead of typing stuff, we are speaking, we are commanding computers to perform certain actions. And if we can only interface with computers through speech, then what happens to the monolingual speakers? You know, maybe people that live in rural areas and only know how to speak isiZulu, isiSotho, etc., etc. That is a problem. Then also, we know that in our universities, there's this language policy that has been given to us by government. And I think generally there's a consensus that expanding the languages of teaching and learning and also research in our universities is a good thing. It may help to make the knowledge more accessible, but at the implementation level, it is extremely difficult to even have a bilingual university where you have, you know, let's say a very low resourced African language like isiZulu, isiXhosa, etc., etc. And it's very expensive to actually translate the materials to develop the terminologies, etc., etc. And these human language technologies can help us and actually remove some of the obstacles to implementing our language policies. Also, an important thing is that I think we agree that we want to continue to attract speakers of our indigenous language. For example, if your home language is Afrikaans, then you want your kids to speak Afrikaans. You want to continue to speak Afrikaans in your family. And that is true for all the indigenous languages in South Africa. However, what happens with young people is that if they are interfacing with their computers, you know, their PlayStation, their smartphones, etc., in English, then these indigenous languages start to be perceived as backwards, as not attractive. And basically, it means that there's a chance that our languages will become extinct, because if we cannot attract new speakers of the language, then naturally that language will become extinct. Also, by attracting those speakers and keeping those speakers, it allows a newer generation to access oral history about their heritage and their past. Because we know for a lot of the African peoples, the history of the peoples is still very much passed down in an oral manner. So these are just some of the motivations why it's so important to develop human language technologies for indigenous languages. Now, today I'm going to be talking about the promise of transfer learning. But before we get to transfer learning, I just want to just be clear or clarify the normal kind of machine learning, and then we'll go to transfer learning. So under normal circumstances with machine learning, we have some data that we feed into a machine learning model. And that machine learning model will then acquire the ability to perform some task for a case that it has not come across before. So we've got our data that we train our model on, and we hope that it can generalize and actually solve a problem that it has not seen before when it is put out there into the real world. That's the normal machine learning context. However, we have also discovered transfer learning, where we try to leverage the knowledge gained by performing a specific task to benefit the performance or increase the performance of another task. And that is the first type of transfer learning that was introduced, at least to us as natural language processing people. So in this scenario, instead of just having data for one specific task being fed to a machine learning model, and that model learning how to perform that one specific task, what we have rather is data for a number of different tasks. So for example, semantic role labeling, part of speech tagging, and also named entity recognition, that data being given to that model, and that model being forced to not just perform, for example, part of speech tagging, but also to perform semantic role labeling, part of speech tagging, and named entity recognition. And basically, the premise here, or the intuition, was that by building a machine learning model that can perform more than one task, that machine learning model would acquire, you know, more general knowledge, which will then improve its performance on the individual tasks. And credit to Ronan and Jason, who introduced, they didn't come up with multitask learning, but they definitely did introduce it to us as NLP people. And what they learned about multitask transfer is that the tasks that you choose matter. You know, there are some tasks that, or some groupings of tasks that better improve performance of that machine learning model. You can't just, you know, take whatever bunch of tasks you want. You have to be actually careful of which task you choose. Also, they learned that the way that you feed in those samples into the machine learning model matters. For example, we could interleave the samples. So if, for example, we could take, you know, 2 from part of speech tagging, 2 from named entity recognition, and keep on alternating like that. Or we could just train the model on part of speech tagging first, then on another task second. The way that we train that model definitely matters. also something that will always be a reality when you're working with machine learning models is that the data sets for the different type of tasks are never going to be the same size. They are collected in different conditions by different people. And so dealing with that unequal size of data sets is a challenge that you need to consider. Also, the model that you choose matters. I think it's important to recall that this paper by Ronan and Jason was done in 2008, and that's a very long time ago, especially in natural language processing and machine learning. There's many more models that have been developed since then, and the type of model that you use for multitask learning will, impact its effectiveness. Then there's also another another type of transfer learning, which is called knowledge distillation. And I'll link you to a great survey paper that you can read there on knowledge distillation. Basically, this concept or this approach was developed because the machine learning models that we currently have, which are transformer models, are very large, and they take up a lot of computational energy, if you would, in order to run. And that is problematic, especially for smaller devices like our phones, because we don't have a lot of processing power on our phones. And also the latency in actually getting a response from a particular technology is an important part of the user experience. If the user is using your application and they're having to wait, then that just has an adverse effect. And so NLP researchers have worked very hard to try to condense these models and create smaller models that are able to perform as well, but use much less parameters, and also therefore run much faster than the big models that we have. And this idea is articulated very well from the people from Hugging Face, which is a library for working with transformer models, where they say distill BERT, which is the smaller version of BERT, a very popular transformer model, has 40% less parameters. So it's, in terms of size, it's 40% less than BERT base uncased, runs 60% faster, which is great because it means that if you're building your technology with this transformer model, then it's going to be much more you're going to get your responses much faster, and there's not going to be latency, or as much latency, while preserving over 90%, 95% of BERT's performance, which is also very important because when we take this large teacher model and we train a smaller student model to do the same task that the teacher model does, we don't want to get a massive reduction in terms of performance. We still want to maintain that really, really great performance, but with less, with a much smaller and faster model. So that is knowledge distillation. And then finally, we have cross-lingual transfer. And usually in natural language processing, we used to do this thing of training a machine learning, like one machine learning model per language. So you have you'll have a machine learning model for English, Chinese, etc., etc. And that has a number of disadvantages. Well, the first disadvantage is that you literally need to train one model per language. And so the admin and the logistics of having to train, for example, if you can think about big companies like Google, et cetera, who want to operate in as many languages as possible because they want to reach as many markets as possible, and they also want people to use their products in their language, it's a whole lot of admin to maintain 100 models for 100 different languages. Also, if we have these separate models for different languages, then it means that we are not leveraging any similarity between languages, because at the end of the day, we believe that a machine learning model, when we train it on a large corpus, for example, it is learning more than simply just, the specific language. We hope that it is. And so if we can teach it on more than one language, perhaps it can acquire language that transcends, you know, those particular languages that it's been trained on. But that is only possible if that machine learning model is learning from more than one language. And also the very big problem with training one machine learning model for different languages is that different languages have different amounts of resources. Yes, you have your English, German, Finnish, Chinese, etc., which will have large corpora, whether it's text, speech, whatever it is, but they generally have very large corpora. Then you have very poorly resourced languages, like isiZulu, isiXhosa, etc., etc. And if you are training one machine learning model per language, you will necessarily have these excellent models for English, but for your low resource languages, you'll have horrible, terrible models. So these are some of the disadvantages of this one model per language approach. So the solution that NLP researchers came up with is that, well, we will train one model on a whole lot of languages. And that means that instead of just feeding the machine learning model with English data, we're going to feed it with English, German, Chinese, Swahili, etc., etc. And it's going to acquire a vocabulary for all of these languages, and it's going to learn how to perform one task in a whole different number of languages. So these are multilingual language models. And also the other motivation for training this model on a whole lot of languages as opposed to one is that maybe those poorly resourced languages like isiZulu, like isiXhosa, will benefit from the highly resourced languages like English, etc., etc. So that is one of the major motivations for creating these multilingual languages. Now, before we continue to talk about cross-lingual transfer, just a word on the transformer models that we are using, because in NLP, we are predominantly using transformer models. And even if, I don't know if some of you guys are also in machine learning, but you've probably heard about transformer models if you're working in like computer vision or even other areas, because like transformers are not specifically for, even though they were developed first in NLP, but they are being adopted in many other fields and they are becoming popular. And I refer you to this great, if you don't know about transformer models, then there's a great article written by Jay that you can read. But basically in NLP, we started off with statistical models, so statistical natural language processing. Then we moved on to neural networks, like little small neural networks with like 3 or 4 layers. And then we went to deep learning, which are neural networks, but with many more layers and also many more neurons per layer. And then finally, we've gotten to transformers, and they are currently dominating NLP, as we'll see later on in the presentation. The important thing that I want to highlight about transformers is that there are 2 steps that are involved when we use transformers for NLP. The first one is called pre-training. And pre-training is when we train this transformer on a very, very large corpus of text. For multilingual transformers, that corpus will be multilingual. For monolingual transformers, it will be monolingual. But we pre-train it using basically, why am I forgetting what ML, the masked language model task, and also the next sentence prediction task? Well, that is what BERT uses. The other transformers will use different tasks, but basically we give this machine learning model some context words, and we ask it to predict one word which has been masked somewhere within a group of words, and also train it to predict the next sentence. And that actually allows it to acquire, this we can refer to as language acquisition, because it simply learns the language. This is step number 1. Pre-training causes that model to learn the language. And after the transformer the transformer has learned the language, step number 2 is then to fine tune it to perform a specific task. Because at the end of the day, that's what we want to do in natural language processing. We don't just want to have a model that understands or knows English or knows Chinese. We want to perform some specific task after we've acquired that language. Now, what are some of the tasks that we use in order to evaluate our transformer models and basically see how well they are performing or how well they understand that language? There's a number of tasks. Some of these are traditional natural language processing tasks. Some of them have been developed recently. Part of speech tagging, where we simply assigning a part of speech to each word. That is pretty much a classical natural language processing task. We also have named entity recognition, which tags the locations, the names of people, the names of organizations within our text. We also have paraphrase identification. For example, given 2 sentences, determine whether they are, one is a paraphrase of the other. We also have natural language inference, where we are given a premise and a hypothesis, and we are asked to determine whether those 2, that premise and hypothesis, is entailment, while represents entailment, a contradiction, or neither. We also have document classification, which is also another classic NLP task. And there's also question answering. And there are various varieties of question answering. There's one where we could literally just be having a little question as text, and we have to choose a single word from a number of options, or we could be given a question and a piece of text, and we have to indicate the span of text that actually answers that question that we have been given. So with our transformer models, as we do with any other NLP models, there's this large spread. I mean, this is really a subset of the tasks that are available to test these models. And it's very important that we have this diverse set of tasks to test these models, because there is no, even though transformer models are dominating, there is no model that is going to be the best at every single NLP task. What you'll find is that different models have different characteristics. And so when we take an NLP model and we test it on a wide variety of tasks that are diverse, then we are able to sort of paint the characteristics of that model and know in which context it's going to do a really great job. And just in case you're looking at these tasks and you're thinking to yourself, well, part of speech tagging, named entity recognition, these are sort of baby academic toy problems that, are not going to make a difference to real life applications. It's important for us to remember that those really low level tasks are the foundation for the kind of user applications that we enjoy and that we want to develop. For example, going back to this issue of implementing the language policies within university, ideally, we would like to have a situation where if a lecturer is in front of the class and they're lecturing in English, then they, a student could possibly put on their headphones, click onto some server and have whatever the teacher or the lecturer is saying translated to them in their specific indigenous language. And in order to make that happen, which I would refer to as a user application, something that's, us as humans, these human language technologies that we use to interface with computers, that's a high level task. But the high level NLP task that would make something like that happen is speech to text, because we'd obviously be transcribing what the lecturer is saying into text, and then also automatic speech translation, because that's when we'd be taking the text and translating it into that student's indigenous language. And that would provide captions, but we could also then from the text do text to speech and actually verbalize what the teacher is saying to that student. So all of those are high level NLP tasks, but in order to create those high level NLP tasks, we need to get the basic tasks sorted, like in terms of part of speech tagging, morphological analysis, named entity recognition, the tasks that you see listed over here. So yes, they help us to evaluate the models and really get the characteristics of the models and where their strengths and weaknesses are, but those problems are actually very important as well in terms of building the kind of user applications that we want to build for people. Now, just to go back to and further make my point about the dominance of transformer models, the great thing about NLP, and a lot of machine learning, like sub areas have this as well. I know that computer vision has its own benchmarks as well. And in NLP, we've got our benchmarks. And here we have the GLUE benchmark, which basically is a bunch of tasks that have been put together. And if you develop your own transformer model and you think it's so great, it's awesome, it's the best in the world, then you can submit that model, or submit that model to the organizers of this competition. They will run your model on the data set and publish your results. And if you look at the top 5 at the moment, all of these are transformer models, which shows that transformer models are dominating NLP at the moment. If you look at Super Glue, which is basically is like an upgrade of Glue, because it includes more challenging tasks and more tasks in terms of quantity as well. There you can also see that the top 5 is dominated by transformer models. And actually you can click on these links and go to these benchmarks, and most of the models that are there are actually transformer models, not just the ones right at the top. So going to multilingual transformer models, because remember, as we said before, while we can create one transformer model for each and every single language, there are some real disadvantages to that. Ideally, we want to have one model that understands a whole lot of languages. And so multilingual transformer models have been developed, which are basically transformer models that have been trained on multilingual corpora. We've got a whole bunch of them, and it's a zoo. I should have said this before when I was talking about monolingual transformers. It really is a zoo. There's so many of them. If you go onto the benchmark and you look at all of the people that have submitted their models, you will see the diversity and the number of models. And the same is true for your multilingual transformers. I've just put down the really popular ones here, MBird's, MT5, Facebook's one, but really there's so many, and you'll see them when you go to the multilingual benchmark. So we're still adhering to this 2-step process, even for multilingual transformers. Step number 1 is to pre-train that transformer model on 100+ languages, and I've got 100+ languages because usually it's 100+ languages. And that's like your language acquisition step. Once we've acquired those multiple languages, we can then fine-tune that multilingual transformer model to perform a specific task in a whole bunch of languages. And here I've got a snapshot of a multilingual benchmark. The ones that we saw before, the GLUE and the Super Glue, those were monolingual, but we also thankfully have benchmarks for multilingual transformers, and they will have also a set of NLP tasks that they measure or they evaluate performance on. But the difference is that each NLP task will have a number of languages. And here you see as well on this leaderboard that these are all transform models, and you can go onto this web page, the link is here, and click on them and read up on them, and you'll find that they're all transformer models, which just shows you, again, the dominance of this particular kind of model. So what are the 2 fundamental, as great as these multilingual transform models are, what are the 2 fundamental problems that we have in terms of using transformers for our 11 official languages. We'll scratch out English. While there are two fundamental problems that are linked to the two steps that I talked about before that have to be implemented when using these transformer models. The first one is that for step number one, we need to pre-train the transformer model on a corpus of text. And a lot of our languages, a lot of our official languages just do not have a lot of text in terms of their corpora. So that's the first problem. The second problem, linked to step two, where we fine-tune that model to perform a specific task, is that the data sets literally do not exist for our official languages. So you cannot even fine-tune a model to perform a specific task because the data set in your language does not exist. So this is important because when we talk about low resource, usually we just say low resource language, but what do we mean? It's actually two problems within that specific phrase. It's the lack of a corpus for pre-training the transformer model, and then it's also the lack of a data set in that specific language that you're working in. And just to emphasize or to further clarify problem number one, there are two major corpora that are used to train transformer models. It's Wikipedia and it's Common Corpus. Now, if we have a look at Wikipedia, there's a link here that you can click on Wikipedia and we'll give you great statistics on how big the Wikipedias in the different languages are. And if you look at this list, you'll notice that in the first 100, so here we've got the rank, the language, and the number of articles. Only Afrikaans, we'll leave English out, only Afrikaans out of our official languages is in the top 100. And it's number 69, so it's respectable. But if you compare the number of articles to the number of articles in English, you can see there's a massive gap there. And then we go to our other official languages. For example, isiZulu is number 156, and it only has 10,500 articles. IsiXhosa, it's 271, and it has 1,200. IsiSotho, even less. It doesn't even have 1,000. So this is problematic. The first problem here, obviously, is that when people are training the multilingual transformer models, they only train using the first 100 languages of Wikipedia. And this is a problem because it means now you will literally not have transformer models that understand isiZulu, isiXhosa, etc., etc. Afrikaans, thankfully, it will be included in most multilingual transformer models. But another thing for us to remember is that on this Wikipedia list, it's number 69. And the amount of data that you have, even though when these multilingual transform models are being trained, you will oversample your languages with less data, so you can try to balance the performance of the languages, the performance of the model in different languages. But you can only do that to a certain extent as well, because you don't want to jeopardize the performance of your model on English, on your German, etc. So there's only so much you can do. So at the end of the day, the fact that Afrikaans has 104 articles on Wikipedia will have an adverse effect on the ability of this multilingual model to actually perform well. And isiZulu, isiXhosa, unfortunately, for all of the transformer models that have been trained on Wikipedia, and most of them cut off at 100, you literally will not have multilingual transformers that know how to understand or that understand those languages. The other corpus that is used commonly to train multilingual transformers is the Common Corpus. And again, you can click here on the link and you'll be taken to a page where they've got the statistics on the percentage of different languages in that corpus. This corpus is much bigger, but if we look at the percentage of our languages in terms of representation, they are quite depressing. you can see here, we don't have the rank, but we do have the actual percentage. You can see English is at 46%, Russian, German at 5%, Chinese, Japanese at 4%. Afrikaans, again, is higher than the other official SA languages, but I mean 0.11, that's puny compared to, you know, the 46% or even the 4% of German. And then you go to isiZulu, which is sad at 0.008, and isiSotho, which is at 0.007. Now, the good thing about Common Crawl is that at least the multilingual transformers that are trained on this corpus will include these languages. So it will understand isiZulu. I'm doing research where I'm actually using a multilingual transformer model that understands isiZulu. But again, it has been trained on 0.0018 sort of percentage in terms of the corpus. And as much as, yes, we can use some techniques to try to create really good representation for isiZulu words, the reality is that the size of that isiZulu corpus is puny compared to the other languages. So in terms of problem number 2, remember, problem number 2 is the fact that for the data sets that are used to evaluate transform models, none of them are in the SA official languages. And we can see it here. Extreme is a multilingual benchmark. And here we've got a list of the languages that are included in that benchmark. And we can see here in the Indo-European family, Afrikaans is there. So that's great. But again, I didn't go into detail, but from the reading that I've done, I know that just because Afrikaans is included in this list doesn't mean, for example, you could have 10 tasks in this evaluation data set, and only one of those tasks include Afrikaans. So the fact that it's in here doesn't mean that there's phenomenal representation. You could find that it's only included in one of those tasks, but at least there is some sort of representation. For the other of our official languages, there's nothing, literally. Extreme has also, in the same way that Glue had an upgrade and it was called Super Glue, so a more challenging data set was created with more tasks. Extreme also did the same thing. You know, it's added more tasks and also included more languages. And you can see in the second paragraph here, each of the tasks covers a subset of the 15 languages. Extreme R adds the following 10 languages. So initially, these are the languages that were there. Only Afrikaans was included. And in the upgraded version, if you go through all of these languages, you'll notice that none of our South African languages are there. So in this benchmark, this multilingual benchmark, only Afrikaans is represented. If we go to another benchmark, XGLUE, also another very popular benchmark. And this one is developed by Microsoft, and they market it while they value this data set. And it is great because it is linked to actual tasks that are being performed by Microsoft products. So it is a great data set. However, if you look at the languages, so here we've got, and this is really transparent and this is really great because on the task column, we have the different tasks that are available in this evaluation benchmark. And then we've got the languages across. And whenever a task has a language, there's a little tick. But if you go through this list, there's Arabic, there's Bulgarian, and you can go through this whole list and you'll see that even Afrikaans is not here. So Swahili is here, so great. There's a language from Africa. Urdu is also here from Nigeria. But out of the official languages, the official South African languages, there's nothing except for English. So that is problem number 2. Literally, the fact that there does not exist a data set in our official languages, which means that even though these multilingual transformer models are doing great and they're performing well and improving the performance of low resource languages, we can't even use them for our languages, we can't even evaluate them for our languages. But there is some promise because what has been demonstrated in research is that zero-shot transfer actually produces great, or not great, it produces good results. And what do we mean by zero-shot transfer? Well, going back to our step 1, step 2, remember that when it comes to multilingual transformer or any transformer models, there's 2 steps involved. First is the pre-training, where we acquire the ability, it's language acquisition basically. Then there's step number 2, where we fine-tune that model to then perform some specific task like named entity recognition, part of speech tagging, etc., etc. So zero-shot transfer refers to the fact that we've taken a multilingual transformer model and we are fine-tuning it in some source language. So for example, we're taking a multilingual transformer model like MBERT, and we're going to fine-tune it on part of speech tagging in English, because while for every single data set in the world, it will be available in English. And we then actually run that model, or we test that model in a target language without actually doing any fine-tuning in that target language. So for example, let's say that I want to do part of speech tagging in isiZulu. Zero-shot transfer would dictate that we take our multilingual transfer model that obviously understands isiZulu because it's been trained on Common Core. We fine-tune it on English because there's no part of speech there. Well, but I do think there's a part of speech data set available for isiZulu. So let's take named entity recognition. We fine-tune it on English named entity recognition, but then we actually tested on isiZulu named entity recognition without any fine-tuning on isiZulu. So that's zero-shot transfer, and that has actually produced some great results, which is phenomenal because it means that even in the absence of fine-tuning data in our low resource languages, these multilingual transform models are able to perform well in our languages, given that they've learned them during pre-training. And then what's also promising is that few-shot transfer actually further enhances the zero-shot transfer. And for few shots, we mean that, for example, we've got our model, multilingual model, we want to do named entity recognition, we fine-tune it on English named entity recognition, but then we also fine-tune it on a few samples of isiZulu named entity recognition data. And by few, we mean 10 to 100, and then evaluate it or use it for isiZulu named entity recognition, and the performance of that model will be enhanced from what we're able to achieve with zero-shot transfer. So this is promising because it means that it is possible for us to use these multilingual transformer models on our poorly resourced languages, although as long as we understand that within some limitations, because the fact that we've pre-trained on such small corpus for our specific languages will have an impact on the performance. And when I say that good results have been reported, this is just a table from a paper that I'm working on, where I'm going through the literature and I'm looking at the performance of the multilingual transform models on different tasks and seeing how well they do with zero-shot transfer. And you can see that they are able to get relatively good performance across a number of tasks. Your natural language inference, named entity recognition, etc., etc. There is a disparity in terms of how accurate the models are on different tasks, but that is to be expected. As I said before, there does not exist one transformer model or any model for that fact that will be dominant or superior on every single task, but rather we must use a diverse set of tasks so that we can see the characteristics of those models. So these are promising results. I mean, if you're getting 93.82% accuracy with zero-shot transfer, meaning that you've done no fine-tuning in the target languages at all, then that definitely is a promising result. But I do want to reiterate that there is no substitute for the two problems that are faced. Yes, there's some promise with the multilingual transformer models, but with machine learning models and with deep learning models, they're very greedy for data. They need more data in order to perform well. You know, there's other techniques and methods that we can try to use and we can try to pursue, but we cannot be fooled. First prize is to build the larger corpora for our languages. And then in overcoming the second problem, we have to, as much as zero-shot transfer works and the results from literature are promising, we still need to develop the isiZulu, isiXhosa, siSotho version of these evaluation data sets, because we have to evaluate how well these multilingual transformers are doing, and we have to benchmark, you know, the performance of the multilingual transformer models against models that have been trained specifically on that language. And maybe that is something that I neglected to say earlier on, is that as much as we have this goal of creating one model that understands a whole lot of languages, and so we run away from that scenario of having to maintain one model per language, it's still a goal and it's still necessary for that one model that's been trained on a lot of languages to be able to perform better than a model that is trained specifically for one language. So it's important that that happens. So even when we are using multilingual transform models for our low resource languages, we also need to have those dedicated models that are trained specifically on that data set so that we can benchmark performance. And then this is, if you look at the numbers, you want to cry sometimes, because it's very expensive, and it's quite difficult to write research grants, proposals, and all of this, because it's expensive. It's expensive. There's no running away from it. This is taken from a proposal that I've written. And basically, I've taken the pause data set, and I haven't even taken the whole data set. This is just the Wikipedia version of it, because there's the Wikipedia section, and then there's the Quora. I don't know if I'm pronouncing that correctly, but there's that website where you ask questions and, you know, you get answers. And I didn't use that data because I don't know, I'm not too sure about the copyright restrictions there. So I'm looking at the subsets of the Wikipedia subsets of the pause corpus. And the pause corpus is used to basically evaluate a paraphrase identification model. So given two sentences, determine whether one is a paraphrase of the other. And you can see here it got a total, the total number of samples is 65,401. And each sample is made up of sentence A, sentence B, and then an annotation that indicates whether, you know, they are paraphrased or not. So you've got 65,000 of those samples, and that's 2.4 million words. And in order to translate that, you'd need about 2.3 million rand, which is scary because, I mean, this is just one data set for one language. How much investment will you need in order to translate these data sets into the other low-resourced South African languages? But I think it's important for us to stare at these numbers and not lie and like confront the reality, because I think as I mentioned here, like there is no substitute for data. If you want to train a good machine learning model, you need a lot of data. And also, if we don't create the isiZulu, isiXhosa, isiSotho versions of the evaluation data sets, then how are we ever going to evaluate these multilingual transformer models on our languages? And if we can't evaluate them, then how are we ever going to build machine learning models and human language technologies for our South African languages? So that is where I will end. And I can take questions now, Mino.
Okay, great. Thank you. Thank you very much for an interesting presentation, insightful. I see that there are a few questions in the chat. I'll do them not really in order. So Tanya has one question and one comment. So I'll quickly start with the comment. So she says, if you check the Saddler repository, and the link is in the chat there are actually quite a few data sets that can be used to evaluate part of speech tagging, named entity recognition, etc. And these are available for all the official languages in South Africa. So there are some data sets. Then I quickly want to add one more thing to that. Last year, the AI conference, the SEC-AR, organized together with the DASA, the Digital Humanities Association in Southern Africa, a shared task on part of speech tagging for the Nguni languages. So that might be something else to quickly check out.
Yeah, can I comment there,
Sure.
before you go ahead? Yes, absolutely. And yeah, that's an important point. And those data sets are useful. But the one of the reasons, and actually this came up as feedback to a funding proposal that I wrote, of why don't, because I wanted to translate an existing data set into isiZulu. And they asked me the question of, well, why don't you just create your own new data sets? And my reasoning was, we'd rather translate an existing data set in isiZulu because that is the data set that is included in the benchmark. For example, I know that, well, I actually need to go and look at the part of speech tagging and the name entity recognition one, but I'm not too sure whether you'll took the existing data set that is used in the benchmarks and translated it, or you'll created new ones. Because the reason that I want to translate an existing data set is that we want to start getting our languages out there into the NLP community. So when they're evaluating their models, they're actually including isiZulu, isiXhosa, etc., etc. The other reason is that we want to compare the performance of a machine learning model on isiZulu against the other languages. For example, for the PAUSE dataset, it's available in 6 languages, and isiZulu is not part of it. But if we add isiZulu as the 7th language, it means that we can evaluate a machine learning model. We can compare the performance of a machine learning model on these different languages and include isiZulu there, whereas we can't do that if we originate our own part of speech or named entity recognition datasets. But I'll definitely have a look at the datasets that you'll have on Saddler and see whether they align with the benchmarks that currently exist.
Yeah, thanks. Just one other comment, and then so Tanya says no, they're not translated. It's taken from actual language data. The problem with translations is that you can't do that one-on-one because of linguistic differences. Anyway, so I think that's a whole discussion that will take a couple of time. One quick comment. Wikimedia, the organization, they actually provide trainings for people to help write Wikipedia pages. So perhaps one of these solutions would be to just get so also Sotho speakers to just add a lot of Sotho Wikipedia articles. I see Nomsa as a hand up, but there are 2 other questions first. So Tanya says, for multilingual models, you will still have very little data, for example, for isiZulu. So when you fine tune on a specific task, will you be using the isiZulu data predominantly, or you will be using the isiZulu data predominantly? How does the multilingual model help in a specific task for isiZulu? especially given the differences between isiZulu, agglutinative, morphologically highly productive, etc., and a lot of other languages with a lot of resources used for the multilingual model?
Yeah, I think to go back to the first question of whether we're going to use the isiZulu data or not, well, that just goes down to how we want to evaluate the model. If we don't use any isiZulu data to fine-tune, then that is referred to as zero-shot transfer. And if we do use some isiZulu data, then that will be few-shot transfer. And also we could just have proper fine-tuning where we do use the isiZulu data. So it's all really up to you which approach you take. And but in terms of experimentation, you probably should do all of them and see which one works best. And then in terms of, you know, how do we know that these other languages are actually going to, like if we're training the model on 100 languages, how do we know that actually contribute positively to the performance of a specific task in isiZulu, given the linguistic differences? You know, if we are, as NLP people, we are empirical, meaning that we run the experiments, and if the model performs better with a specific approach, then we are like, great, it works good. But in terms of going into the actual theory of why it performs better, etc., then I would need to collaborate with the linguist, you know, in order to ask that question. What we do know is that, you know, certain languages will improve the performance of isiZulu, you know, compared to other languages. So you could hypothesize that other agglutinative languages will improve the performance of isiZulu, but if a language is not agglutinative, then it may have a detrimental impact on isiZulu. But again, there are some preliminary results in the literature, but I think those experiments have to be done, and we would probably need a linguist to try to explain why we're getting certain experimental results.
Yeah,
I hope
wonderful.
that answers the question.
Yeah, no, I think that last part was mostly what Tanya was proposing. I do see that we're kind of running out of time, but there are still a few questions. So if you really need to leave, then I'm afraid I can't keep you here. But if you still have a bit of time, then we can still go through the questions.
Yeah, we can carry on. I'm here.
Yeah, cool. So Rod says or asks, do multilingual transformer models outperform language-specific transformer models when there's very limited data for the language-specific training?
That is something, there doesn't exist one answer that I can give. And as I said before, the goal of these multilingual transformer models is for them to perform better, but that has to be tested. You know, it's not the case that simply using this architecture or using this approach is going to guarantee a better result. You have to test that for different languages. And I think if you recall and you go back to that Wikipedia table where the languages are ranked in terms of the number of articles that they have, one could argue that, you know, maybe there's some magical point there in terms of if you have this amount of data, then yes, you know, performance will be better than a language-specific model. But if you fall below that threshold, then it's not going to be good. So I think my answer would just be, we would have to test that for specific languages.
I hope that answers your question, Roald.
Yep, that's fine for the moment. Thank you.
Okay, thanks. Nomsa, you had your hand up as well.
Thank you, Prof. But then I think a part of my question was answered in the previous comment. But then I will go ahead and ask on the case of no substitute for data. There's a paper by Heringer 2015 where they looked at West Germanic languages or dialects with an aim of using the data from those languages to develop Afrikaans in a way that they were recycling the data from those languages as they are the most resourced languages when compared to Afrikaans. So from someone who's from computer science department, do you think that approach can be appropriate for South African languages? For example, in Google Translate, for Nguni languages, there's only isiXhosa and isiZulu. And for Nguni languages, again, isiZulu is the most resourced language. Do you think then we can recycle the data from isiZulu to then develop resources for isiNdebele and isiSwati, as those are considered to be the least resourced languages in the Nguni language group?
Yeah, I think you could try. You could definitely try it. I mean, I don't. There's no theoretical framework that I can refer to say that, you know, based on this theoretical framework, this would work or not. What I would suggest is that you actually try, you know, because, for example, although this is not at a, although this is not at a language level, I know, you know, no, yeah, that there was actually a corpus for that Sakir, for the Sakir conference. It was a part of speech. It was a part of speech competition, wasn't it? Yes. Yeah. So I would say, for example, you could try that. You could try to develop a model that would take, because there were 4 languages there, would learn from the 3 Nguni languages, and then try to transfer performance and improve performance on the 4th language, and then compare that with the performance of a model that's only been trained on that one target language, and then see whether the performance would be enhanced or not. But again, it will just be some experimentation that you'd have to do. Get the isiZulu data, try to leverage it somehow to benefit the lower resourced Nguni languages. It's just unfortunate that there's a technique that exists that works very well for expanding a data set that unfortunately cannot be used for low resource languages, and that is back translation. So let's say we've got an English corpus, and it's just got 2 million words, and we want to make that corpus bigger. What we could actually do is take that corpus, translate it into French, and then translate that French corpus back into English. And what you find is that the sentences would be phrased slightly differently, which will then allow you to make your English corpus much bigger than it was before. But that technique can't really be used for Nguni languages because, you know, where are you going to get a very good machine translation solution that is going to go from isiZulu to isiXhosa, then back to isiZulu? So it's unfortunate we can't use that, but I would just say do the experiments and see whether the larger isiZulu corpus will benefit a much more smaller resource language.
Okay, great, thanks. So Marissa has a quick comment. So they used data from closely related languages to boost machine translation quality when there was even less data, and that didn't help at all. And it appeared that with all small data sets, it created more confusion than solving problems. But the results might be different for classification.
Yeah, I'll absolutely endorse that that view. That's actually one of the surprising things when you look at the literature. That you would think that the closely related languages would actually boost performance, but when you do the experiments, you may find that a language that's further away is actually doing better. And that's where I say there has to perhaps be a collaboration between linguists and computer sciences to try to work out why what we expect to be the result is actually not.
Yeah. Sorry, Chris, I kind of jumped the queue again. Your question was next.
Thank you very much, Sibonelo. I have a question about, so this trend of African languages being low resourced and the idea is like there's not enough data. So like for the Wikipedia articles, there's like very few articles for isiZulu and the other African languages. And then one thing you mentioned about the generation, the young generation, not, being focused more on English. My question is, what do you think about language usage versus just trying to gather data for the language? So for example, the reason why English and many of these languages are high resource now is because they're actually integrated into our, our way of lives, and they're actually being used, right? So, and what we seem to be doing is a concerted effort to just generate data for these low resource African languages. So for example, you could just be focused on generating translated texts for isiZulu to Africans, and then you get funding. But what about looking more into the language usage aspect in terms of, I don't know, products or things that could be done to actually get back the language, to make the language being used in our daily lives, or efforts that capture these languages as they're being used. Just, I wanted to know your opinion on that, because I think, I may be wrong, but I think many researchers kind of just focus on the gathering data stuff, and maybe leave the other part to industrialists. So that, thank you.
No, thank you so much for making that point. I think it's an important one, that it's not just data gathering, but it's driving the use of the language. Absolutely, I think we do need to take that approach, especially when you look at that last slide that I had, where it showed just how expensive it is to create data. We should and we must do that. For example, we know that high school children are writing isiZulu essays. They're writing essays in school. So already there's usage there, and there's an opportunity for us to capture text. And the great thing is that, we would be capturing text that is perhaps of a higher quality than what you find on the internet, because that's also one thing about your Common Corpus. It's wonderful that it includes languages like isiZulu, isiXhosa, etc. But necessarily, because it's text that is scraped from the internet, we don't even know whether that's high quality text. So I think we do need to create some products to capture the isiZulu that's already been written, in addition to what Mina was saying about encouraging students to write articles in our indigenous languages. And definitely those products, we must create those products. One thing that I've thought about at UKZN, because we have this compulsory module, you have to do isiZulu, I think in one semester. As we work to create a spell checking application, a grammar checking application, it would be great if we actually create a web application that we own, that students go to and use, so that we can capture that language and further improve the models. Because that's the other thing, that's why Google keeps on getting better, that as we are writing emails, it's taking that data and it's integrating it into its corpus and training its machine learning models. So I think there's absolutely opportunity in order to capture text that's being generated, but also driving the use of our languages. We could talk about that, but I absolutely 100% agree with you.
Okay, great. Thank you. Thank you very much. I think we'll have to stop here. We're running a little bit over time, but I thought the discussion was actually really nice. So thank you again, Sibonelo, for a nice presentation and a very nice discussion afterwards. I'll stop the recording here.